Thank you for joining our first webinar series of the semester as part of the Marine Institute Graduate Society seminar series. This talk is being recorded and will be uploaded to our YouTube channel, where you can also find most of the rest of our previous seminar series. So before we start, I just want to provide a land acknowledgement. So we respectfully acknowledge the land in which we gather as the ancestral homelands of the Beothuk and the island of Newfoundland as the unceded traditional territory of the Beothuk and the Mi'kmaq people. We would also like to recognize the Inuit of Nunatsiavut and Nuatiavut and the Innu of Nitassinan and their ancestors as the original people of Labrador. We strive for respectful relationships with all people of this province, and we search for collective healing and true reconciliation, and to honor this beautiful land together. So today we will hear from Dr. Ove Tobias Gudmestad from the University of Stavanger in Norway, who will be joining us virtually to give us a presentation on present challenges for the young marine engineer. Dr. Gudmestad has been a professor for cold climate change engineering, maritime technology, and offshore field development. So Dr. Gudmestad has prepared his own introduction. So without further ado, we will pass it off to you, sir.
Thank you very much. I'm very happy to be able to address you. My name is Ove Tobias Gudmestad. As I said, I have been working with the oil industry for a long time, but then I transferred over to the university sector, University of Stavanger, Norway on the southwestern coast, and University of Tromsø, UiT, the Arctic University of Norway, up far north of Norway. And today I will talk about challenges, as they see there, for young marine engineers. There's a lot of things that are expected from you. Okay? What about me? Well, this is me at a younger time. I had my master in the University of Tromsø in applied mathematics. I started work with my employer, and I was sent to MIT to learn more about technology. And then I had my PhD in applied hydrodynamics. And I went over to Texas A&M for a while for postdoc studies. I worked with the oil and gas industry, Statoil, and also worked with Shell, partly with BP. And I was associated with universities from '94 and for some years as a full-time professor of marine technology. I also worked as adjunct professor at the UiT. I had to do a lot of work with the Russians while it was possible to have a good relationship. And I was honorary doctor in Russia. And for my research, I have also listed a file where you can find a link where you can find some information. So I'm talking about the changing your board. Well, that will cause challenges. And we live in an area of very quick changes and readily related challenges. Climate is changing around us. Okay, and we expect that extreme weather is becoming more frequent. Because of this, the conditions at sea are changing. And this is for marine engineers, which means try to include the maritime engineers and those working with marine technology. Okay? And we see that technology advancement is more rapid than ever. But there are still because of that, we have a very high requirements to clean environment. And that's one of the good things that are happening these days. Digitalization is increasing. However, management is not always with us. And I have some comments regarding management. They always would like to reduce spending and more profit. There is one problem, as I see it. You are the young engineers. I'm the older generation, but the older generation is quickly retiring. So where should you have your persons to ask? I'll talk a bit about maintenance. Okay. And then also, I know the political landscape is changing around the world. What does that mean? Climate. The temperature of the globe is rising. Part of that is due to CO2 in the atmosphere. And at Svalbard, for example, Svalbard is at 78 to 80 degrees north. This year, its average temperature was 6 degrees above the average for latest years. That's a lot. And some areas in the tropic are getting unfit for good life. We see a lot of pressure in the African Sahel belt. and also 40, closer to 50 degrees in some of the warm countries. And then I have the main message, whatever I say the rest. The engineering society must cope with the challenges as they arise. If there is coming up flood warning tomorrow, you as engineer and me as a teacher, we must do whatever we can today to stop the consequences of the flooding. Well, we can work on with the politicians, long-term horizon, but also we have to work today. And one thing is because of climate, sea level is rising, and what is called huge challenges for very many of the main cities of the world. It caused huge challenges for the coastal areas. For example, not very many years ago, there was a flooding in New York. The subway was flooded, unheard of years ago. The barriers built on Thames protecting London. And of course, we know about the barriers that are built to protect Venice. And the flooding is also caused not only by the storms, but also the storm surges. The rising of the sea because of the water is pushed up against the shore. The extreme weather situations seems to occur more often. Whether they're more extreme than any time before, that's a question. But they seems to happen much more often. On land, the ground is unstable when there's loss of permafrost, which of course is a problem in the Arctic. And I heard you also mention Nunavut here, okay? Frozen areas. But what's in it for the marine engineers is that underwater slides could be expected. And there was an underwater slide, which you would definitely expect tsunami. And the Arctic is getting more accessible when the ice is melting, and there are very rapid variations. This is global warming by month. You can see here that the black line is from last year. Okay, how much above the average temperature? And we see the black line and the two red lines. They are on the top. Okay, so this is of course of concern because of many of the processes I mentioned are happening because of the warming. Here are some significant climate anomalies in last year. Let's look about the Atlantic. We have Atlantic hurricane season. Okay, above average activity, 20 storms, 7 hurricanes. The warmest on North America was the warmest on record. Okay, and we see here also there's a lot of fires, cyclones. Yeah, we could go much more into details here. And of course, if we look at the information we find on internet, and also on internet, we find a lot of presentation, a lot of papers. This is a concern for very many of the scientists who write about this. Okay, the weather is, the extreme weather is more frequent. What does it mean? It does mean when extreme weather occurs more often. The 100-year design condition, which is the probability of an event happening per year, is 10 to the minus 2 per year. Okay? When the extreme weather is more frequent, the 100-year situation in the past will become the 50-year event. Okay, so this means that if we have a standard saying that we shall design for a 100-year event or 500-year event, whatever we choose, the safety level in the standard will thus deteriorate because we're not designing anymore for the actual extreme event. So this is something that's not included in the standards. it will also take some time to define how much variations there are. If it's really the 100-year situation is becoming a 50-year situation. However, if we have a very special wave condition 1 year, a lot of storms and extreme waves, statistically that will happen. So we have to have larger samples, larger statistical samples to make an absolute decision on this. In the meantime, the safety level could be deteriorating. Particular concern for marine engineers, that's reduced availability to carry out weather-restricted operations, including fishing, of course. The fishermen cannot go out in huge waves, and we expect more heavy weather offshore. Heavy weather is defined as normally defined as the significant wave height and the peak period of the spectrum. So it's not only the significant wave height, also the period of the waves might become longer. The period of the extreme waves might become longer. That means that experience is actually being challenged. We talk about experience, and I'm very much involved in transferring experience. But when we might have to extrapolate from experience. And because of that, we might need to update the risk analysis, taking then also unexpected extreme weather into account. What is the worst situation that has happened at a location? For example, in Europe, in Northern Europe, it seems like the worst situation related to weather happened in the 16th century, 1580s, when there was the Spanish were battling the British, and they're blown all the way from the channel all the way to the northern Norway without knowing where they were. So we must be open to meet challenging weather. Okay? And here I also have a link to the weather climate. Okay. So of course, then we have always to look into to take the weather risk into account. Some years ago, we were involved in looking at how severe wave conditions are possible on the Norwegian continental shelf. Reistad is a senior meteorologist at the Norwegian Meteorological Office in Bergen, and we looked at this, how severe weather could be. We looked at a very, very low pressure situation, less than 925 hectopascal, and we looked at two high pressure situations, okay, particularly the one in the Atlantic. Also, we looked at some higher pressures over Russia, and we found that significant wave height close to 20 meters could be not considered unrealistic. Normally, the significant wave height for the sign is around 16 meters. So we had predicted a much larger extreme weather. And actually, in reference also to January 1993, there was a very low pressure situations. Okay, wait a bit here. Sorry, hectopascal is a small h, capital PA. Don't catch me there. Okay, so this is what we can expect based on the meteorologist's information. Okay, and are we going to be very worried? Because there are a lot of oil platforms in the North Sea and up along the Norwegian coast. Well, with 20 meters significant wave height, is close to the extreme wave height. It was also looking to design. When we look into the design, we design for the 100-year wave conditions or 100-year weather. Without, then there should be no damage. Okay? And we design for a 10 to the minus 4 exceedance per year event. We could talk about a 10,000 year event. the event where we should have no progressive collapse. So the platforms are actually designed for this situation. Whether this is correct, this was the best we had in 2005, and I'm quite proud of this paper. Okay. Conditions at sea are changing. We expect more icebergs being created from the glaciers. However, we expect less icebergs around in the Atlantic. How could that be? Well, the warmer sea temperature would melt the icebergs more quickly. So we might not expect a higher number of icebergs on the Grand Banks, for example. But the higher, warmer temperature challenges life conditions of fish and sea mammals. Fish thrive at around 0 degree Celsius in cold water. When the temperature rises to an average of +2, the fish might not feel comfortable anymore. And we also know that the sea mammals, particularly seals, they are find no way to no ice where they could stay. Fisheries go north. On the Norwegian shelf, we see that the fisheries move north towards Spitsbergen and north in the Barents Sea when the fish population is moving. Well, we have the big problem with coastal erosion. Coastal erosion is because of the waves and the storm surges, but with less ice in the fall. Okay. So the ice is not covering the sea in October, November as normal, but in later in December. We have a larger season for big storms, a longer fetch length for the big waves, again increasing the coastal erosion. And then with the coastal erosion along the coast, the sandbanks, mudbanks are occurring because the coastal material, the sand or the clay, is not going anywhere. It's going to be dumped on the seafloor, and which means that the electronic drafts are becoming unreliable. Okay. And with warmer waters also, if the temperature at the seafloor is increasing, we have also the melting of the permafrost in the seafloor, and we have methane emission and warming of the globe. And of course, the seafloor slides. The storm surges will challenge the harbor docking more as well. Yes, we know that in the big typhoons but in the Southeast Asia and China, the vessels are not docking during typhoons. They go out and go away from the typhoon paths, okay, because of the problems, huge wind conditions and also waves in the harbors. Okay, I mentioned that icebergs melt before they reach the Grand Banks. How can we cope about this? Well, I say that we carry out risk evaluations. What can happen? Okay, what is the probability of the event we don't want to happen? And what are the consequences? And we have to put in mitigating measures if possible. For example, to stay out away from the path of the hurricanes or the path of the typhoons. And this is probably what you have been taught in classes, so there's nothing very new here. But what I will also warn, that company management are lawyers and economists, very good in their trades, but they might not have a proper understanding of the situation. And they might resist changes. So if you tell them that you have to put up certain measures to avoid the consequences of a storm, okay? No, we cannot go out in the sea and do some work this week because the weather forecast is really bad. Okay, I might not understand it. And it's very important then that we have a good understanding between the groups. I talk here about the marine engineers, but we also need in any company, we need assistance from economy people. If there is no income, there is no salary. We need the lawyers to take care of the rules and regulations, okay, and our businesses. Technology advancement is very rapid these days. And continuous upgrading of the IT systems are needed. I really struggle with this. And there's always something new and the IT system doesn't work, but okay. But for the marine engineer, you have new materials. It's interesting that aluminum, for example, is an interesting material for cold weather. We have new technology because the Finnish, they made up double-acting ships. What is that? Well, in waves, the ship moves forward with a bulb bow. In ice conditions, the ship moves backwards. Because backwards, they have an ice-breaking bow. So it can go both forward or backwards. We have also the new fuel technologies. There's a lot of pressure to go away from hydrocarbon solutions to hydrogen, ammonia, batteries, and so on. And this, of course, will require new knowledge. We have hybrid fueled engines, for example, LNG plus batteries. They are, but then you also need to know how to handle these hybrid fuel engines. And of course, some of these are concerned with fires like batteries, concerned with explosions like hydrogen, concerned with very toxic fuel, fluids like ammonia. Listen, if you try to think that I'm giving up, that's not the case. I'm saying that we have to look into this. And these are challenges we have to meet. Next thing is digitization. It's becoming more and more important, which is very interesting and help us a lot. But there is a possibility of cyber attacks. In northern Norway, our friend and neighbor is jamming the systems. We can expect cyber attacks. For example, the Maersk, the big container liner, they had the cyber attacks. They lost tens of thousands, tens of millions of dollars in a cyber attack. All their computers were broken. We have the electronic charts. What happens if there is a cyber attack? The electronic chart machine is black. What about the plan B? Next thing is autonomous shipping. Okay, in the extreme situation, that means that there's nobody on board the ship, but it's steered from shore. There's a lot of push for that now. Yeah, I mentioned new material doubling here. Okay, that should be taken out. And they expect that the young engineer should master both the new and the older technology. It's not necessarily expected that I, the senior, should master the new technology, but it will help a lot if everybody masters both technologies, but in particular the new generation. And that means not only the new, but also the older technology. Okay, so it's not only okay to run a big computer program and get out a result. You must also know very much what's input to your computer program, for example. This is when you go back to the older technology and look for real data. So conclusion to this is IT knowledge is becoming more important. However, practice is more important than that. And you might have theoretical knowledge. You can read a chart. You can use electronic mapping equipment, but you might not be able to steer a ship. That's why training is needed in order to solve equipment failures and the plan B. Here's a situation in 2 years ago where there was a fire on a ship. Okay, 300 persons were on board. I think this is sort of a cruise ship. Nobody was injured. What happened? Well, here is the Danish Maritime Accidental Investigation Board. We have for the last years, and I also think you have been told that the person is a shortcoming. Failures are due to persons. Well, it's partly the truth. Failures are very often due to persons. However, the Stena Scandia situation, the human skill and adaptability, the persons on board, the captain and the crew, because they knew how to handle the ship, they were able to recover, so nobody were lost. So the personnel is part of the problem, but it is also the main solution. We have the requirements to clean environment, and it's more and more important. And fuel emitting lesser pollution is always pointed to in order to reduce the greenhouse gas emission. And the regulations are issued by international maritime organizations. There are local rules, like in the Mediterranean. There are most of the harbors there does not accept ships with heavy fuel. And then many of the older cruise ships are banned from these harbors. And in 2 years ago, it was not permitted for ships in the territorial waters around Svalbard, again 78 to 80 degrees north, to have on board petroleum-based fuel with high viscosity, meaning heavy fuel. Then that's on the fuel. But if you use light fuel, of course, there's a lot of possibility to improve the fuel efficiency to travel at an optimum speed. Okay? An optimum speed will normally mean much less than the maximum speed. Okay? It can take a day longer for transport. Maybe that's also economic viable. You save so much fuel because if you double the speed, you find the fuel used is typically 4 times more. Then we have the minimum waste, minimize the waste and collect the waste for collection and handling onshore. The ballast water management is becoming more and more important. We don't want any ballast water from very warm countries up in the Arctic. Suddenly there is a species there saying, "Oh, wonderful cold weather," and they thrive and kill everything else. The king crab, the huge crabs, they came along from the Sakhalin area from the eastern Russia, and they came to the Barents Sea. They kill everything around them. Okay. And we say that the fuel must be efficient for the marine operations. However, whatever we do, the safety issue is number one. So the safety of the crew and the passengers, okay, will be number one. Here is one example, the soot particles on the ice. And you take the soot particles to spread soot or ash on ice or snow. You know that is a way to melt the snow. Well, as soon as the sun comes and temperature is getting a bit warmer, and in the spring the sun comes up, and the black will absorb much more the heat from the sun. So that again means that we should avoid the heavy oil. Digitization. Well, maybe I'm old-fashioned, but they keep the old charts as backup. Old paper charts. Maybe you will be ridiculed if you keep the old charts on a boat. If you go out there in a boat or in a support boat or in a fishing boat or in a research vessel, you might be ridiculed, but okay. You try to find a joke so you can keep the charts. Because communication can black out. It could be cyber attacks. What about artificial intelligence? Well, artificial intelligence can look through thousands and millions of documents in a quick period. And they can put together information from one document to another document. But I don't think artificial intelligence really can generate a new invention. I can say here new information. It's new basic information. I say keep a plan B. Also, communication in Arctic waters is very challenging. And satellites will improve this situation, but then we are dependent on the satellites and again the cybersecurity. So I say that they keep the backup solution to ensure the safety of the vessel, the safety of the crew and the passengers. Then I come to one of my pet subjects. I worked in industry, I worked at the university. I had some wonderful, good managers. I had some very poor ones. Okay, but the industry, what's happening in the industry, and not only for marine engineers, but the products shall be delivered within very less working hours. As far as I understand, Amazon is a company really pushing the delivery. And that's a lot of stress for the people, and the people are getting very stressed. There are failures, and there's less time to recover. Okay? Less time to recover for lunch, less time to recover during a break. Many people, they have the computer on 24 hours. They check the computer, the information at 12 before they go to bed. I check again at 7 o'clock in the morning. Maybe there is some important information coming up. And also, that's for the marine staff, the cheapest possible employees. And if you can find some employees, the sailors, somebody in a different country offering much work for much less salary, they're given the job. And employees are spendable. So then they will try to reduce the salary, while they, meaning the management, take higher and higher benefits and salaries. What was Elon Musk's benefit package last year? I think it was in the order of hundreds of $millions, whether it's Canadian or US dollars, or it would be the same. So this is the treatment, the treating of the persons, and then there's less fun for robust engineering. One of my colleagues many years ago, He was leader. He was the chief engineer in a big company. He was called to his boss. The boss said, "Mister, you have had no accident in your area for the last years." And my friend, my colleague, he became very proud. "Yes, sir, there was no accident." But the boss said, "We cannot continue like this. You are spending too much of my money doing robust engineering." Well, I'm not saying which company that was, but to me, that's a new type of managers you can meet. And they require loyalty, even if you work against your conscience. You have to fight, you have to leave. And there's increasing profit requirements. And I'm absolutely sure that there will be use of artificial intelligence more and more without checking out whether the results are acceptable. And then the company lawyer may show up and say, "Hey, John, you're not doing your job. Maybe because you don't follow all these rules." But there is also the good management, handling the employees fairly and caring for the well-being. If you are sick, it's okay to stay at home to recover. Respect the employees' values. And whether the values are religious or they shall be respected. However, good management will also require hard work. Don't think that a good management will allow that you don't work hard. And then there will be benefits, salaries, and so on. And they prioritize safety. They don't ask the ship or the captain to leave the harbor when the captain says we cannot do it. And they demand that everybody do their best. And then there's a humble approach when meeting others. Okay? Meaning that when they meet you, the boss is not he will ask, "Who are you and what you do and what's your interests?" And not just expect that you will be the servant. And sustainable private lifestyle, also by the management. And a term from Berkeley University was high reliability company. A company that worked according to many of these requirements. I was very impressed with this term when it came up. I don't hear it very often these days. Maybe that's a term that should be revitalized. Experienced engineers are retiring because if they work in a dysfunctional company, they will retire as quickly as they can. In some countries, that's the late 50s. In other companies, that's the mid 60s. However, if people are getting worn out, they should be able to retire without being pushed to death. But with everybody retiring, who will assist you? I say without supervision, assistance should be a better word. So when the generation retires, there should be technology transfer. Like one company, the retired asked, "What shall I do with the information I have gathered? Shall I put it together like learning from projects?" "No, we don't need anything from you. Just trash everything." That was one of the most stupid solutions I ever heard. However, the old generation must give you responsibility. So if you are 22 starting in a new company, you can expect the responsibility. But if you have worked the company for some years, you soon should have responsibility, take over. And eventually, your boss will become your advisor slash assistant. Okay? And experienced engineers, I will always have in mind that jump to conclusion, jump to new and unproven technology, and not documented. That's very skeptical against that. And we have what we call technology readiness. Technology readiness. How ready is a new technology to be used? So here I'm not talking about all the good things of the experienced engineer. We're talking about working together. Equipment maintenance. Yeah. Useful equipment should be reused. That's about also sustainability. And not all companies may afford new equipment, but new equipment can be repaired. Older equipment can be repaired in many cases. That means that you have to select a robust maintenance strategy. In some countries, they had no maintenance strategy. That was one of the problems in the Eastern Europe. They didn't maintain. And that's why also a lot of equipment deteriorated very quickly. So you have to select whether you have regular maintenance or maintenance on demand, maintenance when there is necessary. But of course, we have to repair when they're about to break. So there will always be some maintenance on demand. But regular maintenance, okay, keeping the machinery greased, checking they're having daily checks. If there's no maintenance, your equipment will stop or collapse. Without oiling the equipment, greasing the equipment, the maintenance, there's no particular maintenance philosophy, will stop. Corrosion is, of course, a challenge, and we have to know how to limit corrosion and use material that do not corrode, and also use connections that don't work. One is not one work as a node, corroding, okay, in a system. So maintenance of safety equipment is, of course, of highest attention. Safety equipment in a car, for example, what's most important is the brakes and the steering. Okay? Where you have some rust in the hull of the car that might not be so important, but the safety critical system on a ship or in your facility has to be maintained. Here I have sort of a new equipment, new nozzle, except for how the maintenance. And when it came down to minimum acceptance standards, there was a repair. Okay? And without repair, we will have it deteriorated very quickly for this type of equipment. This is from actual situation. Heavy duty gas turbine operating. And we have first repair and the second repair and the third repair up to minimum acceptable standards. And then eventually the repair costs exceed the replacement costs. You see here they have several series of repair, first, second, and third. There might be more, and you can see you can see at the right side, the cost is a very important factor here as well. There's a limit to how much we can repair, of course, without getting very close to deterioration. When there is no steel left in the structure, of course we have to replace the supporting steel. However, you might like to look at this. This is not my recommendation, that's not, but this is how many people think. We have a thing, doesn't work. Yes, don't mess with it. Don't do anything, no problem. Does it work? No. The first question is, did you mess with it? Okay. Then you are in a very bad situation. Okay. Will you tell the boss? No, not necessarily. Then you can also be in a bad situation because the boss can say, you did, you made the problem. Okay. So, well, I couldn't resist putting this in, to show you that I'm not that serious and that old. Okay, the political landscape is changing. The political landscape is under large changes. The discussions are hardening and there are bullying in the politics. Not to mention any names, not to mention any countries. Me? No, it's not me. Well, trade wars are common now. And there is more and more custom coming up. But some countries try to obtain monopoly on important minerals. And it's very dangerous. Okay? And then they will not sell these important minerals. Okay, so for example, in Africa, very much of the important minerals produced in Africa are now taken care of by China. China is getting a monopoly of some very important materials. Good for them, but not necessarily good for the world trade. And also products are produced with loss to obtain monopoly. That's that's an interesting way to manage monopoly. Cybersecurity is under pressure. Cybersecurity generated not by crooks, but also by other countries. The political landscape, cheap labor from somewhere can replace your job. But we must act according to our conscience. There is no excuse for committing crime, saying that the management told you to do it. Then we are back again to the war situation. And what's also very sad is that peace is not longer granted anywhere. So the last one I have is communication. It's a clue. This is a cartoon that was prepared several years ago. Marketing requested or is a swing, bit strange swing. The sales, the procurement people, they ordered a swing that really doesn't work. The engineers, they didn't understand anything. They made a big mess out of that. The fabricators thought it was just a place to sit because they couldn't understand it. A manufacturer something, which could be a nice place to sit though, but it doesn't work like a swing. The operators installed it and they knew that it should be a swing. So they installed this new type of equipment in like cutting the tree, killing the tree. But what I wanted was just a tire for a kid to sit like a swing. Well, this is a cartoon, but that's lack of communication. And it should be possible to talk. And we know, for example, between Europe and US, or also within US, one way to really miss communication, if you don't specify whether we use US units or SI units. There are very interesting examples where I specified units where there were a lot of numbers on drawings, and they interpreted that as SI units, but it was US units, inches, rather than millimeters or centimeters or whatever they, and pounds rather than kilos. So communication is a clue. I am confident that these challenges can be met by the young engineer who really want to go into this marine trade, and I can wish you also good luck. And this is a good life of marine engineer. We were up to Svalbard, looking at the survival in the ice. I was here, the scientific responsible for this task, and we tested out the goodness of lifeboats and life rafts. You can understand here is very, very busy work. However, sometimes it can be real nice. So I also offer my email address here. Okay, that was my presentation, and I expect that there will be possibility for questions. Let's see here if I can go out from. Well, I keep my slides if there are some questions. What I will do, I will slightly update. There was 2-3 printing errors here. One embarrassing hectopascal, but some printing errors. I will update them and send them to your contact person so she can share my presentation. Thank you.
Yeah, and this presentation will also be recorded, so everything will be shared with everyone.
Mm-hmm.
So yeah, we do have a couple minutes for questions if anyone in the audience wants to ask.
So can I ask a question?
Yes, you can ask a question.
First of all, I would like to appreciate it's a very nice and eye-opening presentation. Thank you very much. And in your opinion, I wanted to know that in your opinion, do we expect should expect any crisis in future because of these challenges to the industry? Because I'm myself a marine engineer. Even I encourage my students also to take part in this seminar, but unfortunately they had a class and they couldn't attend. But I believe, that's what I see, from the present situation, that in future, we're going to face crisis because the managers, they do not, as you mentioned, they do not understand, the challenges, ahead of us. So what do you think of it? Do you think, is it going to happen? Do we expect, we should expect any kind of crisis in future?
Well, it also depends upon the politicians, I think. Okay, it's not only management, but also the politicians. Whether there will be a harder discussions between Europe on one side, US on the other side, and China on the third side, and whether Russia can come back again into the fold. Okay, but what my message is that we educate engineers. There are young engineers, and they have to look in and be able to best possible to solve the challenges as they come. That's our job. When I started to work, we had this ad in the newspapers. Our engineers, they sleep with the boots on, always prepared to do their job. That's a message we can give, and that is also a very, very positive message that I can do a difference. If we go around and say that we expect crisis, we will be lame. We cannot do anything. We cannot mobilize. Okay, we are mobilized to do our best all the time. That's my main message, and communication is part of that. But
you
of course, we have the politicians. They can look at this on a much longer term. But I know some engineers, they will also become politicians. The politicians has to be there today. If there's a flood, there is a hurricane warning over Florida today. They have to do something in Florida. What they do today? They put boards outside the windows. They do something today. This is where we are.
Thank you very much.
We have another question.
I have sort of a similar question along the same lines. I think a lot of the problems that you presented have easier solutions than others. Specifically, the extreme weather due to climate change, I think, is a problem that's obviously not that easy to solve. And so my question is, do you think that we'll be able to solve these issues or come up with solutions as fast as they're coming? Because climate change is happening and is continuing, and these weather events could become even more common. Could you provide or think of any examples of solutions to this, or do you think that offshore work will just become less feasible as the conditions get too dangerous?
Well, it will still be feasible, and what we are doing is we invest in the weather forecasting. We will invest in the meteorologists. The meteorologists will be our best friends. If they can predict the weather, forecast the weather longer ahead with more information, that will help a lot. But I will expect longer time for waiting on weather. I expect more time in the harbor when it's not possible to do any work. But I expect that with better weather forecasts, and we still be able to do a lot of work. But this is also the message to management, to meteorologists. Expect that there will be more harsh weather, and that things can take longer time.
Awesome, thank you.
I also have a question. So first, I really enjoyed your talk. I thought it was actually very interesting for someone that doesn't know that much about marine engineering. But I was wondering about what you were saying in terms of the knowledge change between young engineers and older engineers, and specifically like with older engineers retiring very quickly, with the change in like ethics in management. I was wondering if you had an idea of if the training for these new engineers is adapting at the same rate that technology is advancing, and whether there's a change or a link up between like the training for new engineers and the advancement in technology for new engineers.
Well, as when you start studying, you have to know the basic principles. What I also see is that if you say that we have to put priority on artificial intelligence in our engineering studies, I say no, please. Okay, we have to go back. We have to know the basic principles, and knowing the basic principles also, I think you are better suited for the challenges coming up. Okay, and one should never give up. There will you will have all through your life you will have to learn. Okay, I was hired as IT specialist as assistant to my professor when I finished my master. He didn't know anything about using any type of computers. No, I have a very big struggle to follow on, but I've had lifetime learning, and lifetime learning will compensate for what you say. If you think you are educated, okay, if you think you have finished your education, okay, you're not educated, but you are finished.
Okay, thank you. I also have one more question that I guess Hannah kind of asked earlier, but in terms of the change in adapting climate and having to gain a larger like sample size to understand the uncertainties of building like forecast models. I wanted to ask if you knew how accurate those models or predictions can be with so much uncertainty surrounding weather and like changing ocean climate and all that.
Well, you're talking about changing also, when you're talking about changing climate, then you're talking about the longer term. Forecasting the weather for next week or no next month, that should be potential. There should be a potential to do that. Okay? But for longer term, say for what will the situation be 10 years from now, is much more difficult. Then you are depending upon very uncertain models. Not they cannot use any data. You cannot use satellite information. You can't use any information. But to determine the weather next week should definitely be possible with a lot of quite a good accuracy. However, there are still not possible. There's still no good model to prepare to predict or to forecast the trace of a hurricane, and the trace, the eye of a hurricane can move in almost in any direction. And we see that with the prediction, we know where it is today, and the area where the hurricane can come is wider and wider with the days. I think with better forecasting, we should be able to narrow this information for coming days, for coming weeks, okay, but definitely not for decades, okay. But humans have never been able to make predictions for decades. Like in the 1950s, so there was 1940s, 1950s, there was a drop in temperature compared to the decades prior to this, and we will not be able to make accurate predictions for the 2040s. Okay? We can make models, and there are a lot of people making models, and a lot of people claiming that my model is accurate. I say that there is a lot of uncertainty in your model because you have to base yourself on some assumptions. Mathematics is a wonderful one because you make very, very strict assumptions. You follow these assumptions and you find an answer where you can put the line under. This is true. But you cannot do that with these physical activities.
All right, thank you. I don't think there are any questions online. If anyone in the chat wants to ask a question, if you could raise your hand. And yeah, there we go. I think there's one question. There we go. Hello.
Yep.
Hi, can Dr. Gudmestad hear me?
Yep, I can hear you.
Okay. I think my question here for you is, do you see reasons or do you see evidence for being optimistic about where the direction of the world is going with regards to addressing these very pressing problems? I'm asking this because maybe this is just my sort of very jaded perspective, but I almost feel like there's this sort of like a lack of optimism or a lack of hope in actually addressing these very pressing problems. So do you see evidence on the contrary, is my question.
Well, one of the reasons why I took this theme for my lecture is because I'm an optimist. I think that we can do a difference. Okay, whatever situation is, we can do a difference. Okay, that's number one. and we can contribute. Okay, we are engineers. We can definitely contribute, but I'm not saying that, for example, a lawyer, a different trade, they can also contribute in a very positive way. Everybody can contribute in a positive way. But when it comes to evidence, of course, we are then also depending upon the politicians, okay? Because there is say that we can never be guaranteed peace, okay? And many people, they put their optimism to UN, okay? But then we are into politics. When it comes to politics, I tried not to talk very much about politics here, but as engineer, I'm very optimistic that I can contribute. And that's why I am, and that's what I will share with you, that with a good education, with a good will, okay, with a good trust that you have, that you are able to contribute, you can contribute. That's my optimism.
He has given a thumbs up, so I think he appreciates that answer.
Yeah, okay. Because please be optimistic, because with you're taking on this education, you can contribute. If you have a friend who is a carpenter, please tell your friend that he can contribute or she can contribute. Okay, doing the best they can, building houses that are built according to standards, for example. Everybody can contribute. That's my idea.
Okay, thank you. Yeah, no, I accidentally muted myself earlier and then I can't unmute myself. I think I should also read a question that came up in chat. So Angie wanted to ask you, would you say that moving naval engineers to shore would be helpful under the increasing challenges, opening the chance for marine autonomous ships to foster in the near future?
Well, the autonomous shipping is, of course, is an interesting phenomenon. Because you don't expose people to like you do when they are on board. This will, but there are two questions then. What is the educational requirement for these new naval engineers? How can they understand to follow the ship without if they are not being on board a ship for training? So naval engineers, the curriculum, what are they supposed to know? That's one very interesting question. And one of my PhD students, he's actually working on that. The education for the new naval engineers. Okay, that's one thing. The second thing is one of my concerns is also the connection between the shore and the ship. I've talked here a lot about the cyber, okay, cyber security, and I think the cyber security has to be better granted in order to ensure safety for not only for the ship and the cargo, but also for the other ships. So cyber security will be one of the main concern here, and I expect that you have to, for naval engineer to sitting on shore, must have even more knowledge than is required to follow the boat, to be on board a boat, because a naval captain on shore, he or she could very well be a lady. It must have also experience how a ship will react in case of emergency.
Very good. Yes. Thank you. Yes, Angie also gave a thumbs up, so.
By the way, there is also, of course, advantage, not only advantages for safety of those on board, but also advantages for handicapped people. They can be naval engineers and be on shore. So there are also advantages in this, but this is one of the area that will move on, and we follow that with interest.
Excellent. Is there any other questions in the room, by the way?
Nope.
Okay.
Nope.
Okay, then I think I have just sort of like one last big sort of question, and I know it's, you know, I know we're not really talking about politics, but I guess this question comes a little from a kind of as a higher level. Um, what do you think about this notion that a lot of the problems that are being perpetuated comes from sort of a fundamental aspect of Western society, which is the fact that, you know, capitalism, you know, as a whole, is the system that underpins sort of everything. Is there is that underpinning system, um, you know, sort of a cause to these sort of environmental climate issues? And is it an issue of sustainability under the system that really will drive us to, you know, off the edge of the cliff kind of situation? So I ask this because if you look at, for example, you know, the sort of the overarching system, it's always, you know, go for more profit, more profit, more profit, as if there's this sort of this unlimited growth in the world. But the world, in terms of the planet and also its own population, at a certain point is going to reach sort of a finite level. So is it, you know, like, can this problem really be fixed, or is it the system as a whole that's now so flawed that in order for us to fix it, we'd have to remake the entire underlying system?
Well, they're not talking about politics, which is also very difficult, of course, but it has to do with between greed and sharing.
Yeah,
Okay?
right.
And there are also in many systems where there's a lot of sharing. Let us take one organization, Salvation Army. They're sharing, okay, and they're not working there for greed. When I was to India, I was just visiting the Sikh temple.
Mm-hmm.
I was offered free bread, okay, free very simple meal, okay.
Yeah.
That's also sharing. Okay, and we also see that you will ask about capitalism. Okay, we see that also in some other countries where there's not capitalism, there's other type of social system. People are also haunted there. The workers have not very much better situation there.
Yeah.
And when there is a need for increased production, how has increased production being catered for there? There's more and more coal-fired plants are being opened, while in the so-called, when you say capitalist system, the things can be regulated. Okay, so it I don't it is I think that's promoting sharing in all ways. That will be whether it is one system or another system. Okay, I think that's the clue to sustainability.
Okay. Yeah, because I think yeah, kind of like the root of my question is that yes, there's people who are out there doing good, and people out there who share, and people who do all those very positive things. But I think from a lot of the way I see it is that, like, between them and now the people who have the wealth and the power, there's this growing disparity, right? Like the rich and the powerful are getting significantly more rich and significantly more powerful. That it feels like the things that I do, for example, as an individual, just doesn't feel like it's doing much. I think, you know, and I'm not trying to be negative or pessimistic here, but it's a feeling of, um what's the best word here? It's a feeling of inadequacy. It's a feeling of not being able to do enough or not being able to contribute, right, in this
Well, if you
bigger picture.
yeah, but if you compare some of the countries, um, let's say take Germany and England. When I was a young man, the London fog killed hundreds of people every winter because there was so much pollution in the air. The Ruhrgebiet around Düsseldorf and the central industrial area of Germany was so polluted that people died there. So also these systems, they have a possibility to make improvements, and it's also possible for people to vote in a democratic system. Okay, to vote for better situation. It's for example, was 100 years ago, Rockefeller was the richest man in the U.S., but they tore up his conglomerate of companies, and they have anti-monopoly situation. Okay, so it is possible also to with the correct politicians to make changes to this. You don't need to go to Cuba to have better sharing, because the better sharing became that everybody became so poor they couldn't afford anything.
Of course, yeah.
So
Thank you.
that's also really not a good. That's really a very extremely difficult situation. And then as soon as it became possible to earn money, people started to want to earn money there as well.
I appreciate your
So
insight. Thank you.
so my message is that we and particularly the engineers, whether mechanical, naval, civil, electrical engineers, they can contribute with new ideas, new solutions. And if you have a new solution, if you earn, say, in the end, sit there with $20 million, nice house, well, you come up with something that's really a solution. I'm not talking about $2 billion, but let's say if you come up with something that really contributes, okay, why don't also let these people have some special benefit? That's capitalism, but the greed is very different.
Yes, I think it's a very good point. That is all the time that we have for questions. So
Yeah.